In this video, we are going to understand some of the important products obtained from the chlor-alkali process. Well, first you should know why this is called chlor-alkali process, because in this reaction, the product so obtained is chlorine, right? Thus, chloro word has come from chlorine, and another product is sodium hydroxide, which is an alkali, and that's why it's called chlor-alkali process. Now, for this, what do we do? Actually, we pass electricity. As you can see, we have taken a container, is a kind of electrolytic electrolysis in which we take a container and put a aqueous solution of sodium chloride. Sodium chloride aqueous solution is also called brine here, right? That's called brine. We put two electrodes. As you can see, the electrodes taken here is one negative and the other is connected with the positive terminal of the battery. You must be knowing the one which is connected with a positive terminal is called anode. The other which is connected with a negative terminal is called cathode. So once again, we have taken a solution here. The solution is, this is solution that's called brine. That's a sodium chloride. Aqueous solution of sodium chloride, that's called brine. Then we take two electrodes, one connected with the positive terminal called anode, the other, that's a carbon rod here, that's a graphite rod, which is connected with a negative terminal. When electricity is passed through it, right, there is a decomposition reaction takes place. Let's understand what does decomposition here takes place. Right. So this is sodium chloride aqueous. That means this together is brine, right? This is brine. So when electricity is passed, three products are formed. One is chlorine gas, second is hydrogen gas, and the third is sodium hydroxide. These three products are formed in this reaction. Now, besides knowing these products, we should also know that where these products are formed. Now, what is important here, that chlorine, being negatively charged ion, is produced at the anode, right? And hydrogen being positively charged ion, is produced at cathode, that is the negative terminal. And this sodium hydroxide, look into this. This is sodium hydroxide. This is produced near cathode. This is near. This is cathode, and you can see is produced over here. So it is produced near cathode. It is important to remember the where are they obtained. Chlorine is released at anode. Hydrogen is released at cathode, and sodium hydroxide is produced near cathode, right? Now we are also going to understand the various uses of the product so obtained during this reaction. Let's understand one by one. We are starting with this chlorine. Let's say chlorine. Chlorine so produced during the reaction is used as a direct product for, as you know, chlorine gas is used as a disinfectant, right? It kills bacteria. So it is used directly for water treatment. Also, it is used in making PVC, that is polyvinyl chloride. That's an insulating material over the wire of electric wires. Besides that, some pesticides are also obtained from this. CFC, chlorofluorocarbon, although its commercial production is banned now, but it is one of the product obtained from this chlorine. Now let's come to the next product, that is hydrogen. Hydrogen so obtained during this reaction has also various uses. It is used as a fuel, not as a commercial fuel, but it is used as a fuel in many places. Then it is also used, this hydrogen gas is used in a process called hydrogenation. So hydrogenation is a process in which unsaturated fats, it gets converted into saturated fat. It is used in hydrogenation process. Besides that, you know that hydrogen combines with nitrogen to produce ammonia. This is ammonia. Just a second. This is ammonia gas produced here. So this ammonia is produced. Besides this, hydrogen is also used in making fertilizers. So these are the uses for hydrogen gas so produced during this reaction. The next is sodium hydroxide. The sodium hydroxide, this is NOH. Its use is, it is used in degreasing metal, like to remove the layer of grease over the metal. Also, it is used in the soap and detergent industries. There's one more use where we use it in paper industries, or also artificial fibers like nylon. So these are the uses for the product so often. So the important thing that you should know, that what is brine here, that is brine is this whole together, right? Not an whole NaCl, the aqueous solution of sodium chloride. Then the product so obtained is chlorine and hydrogen. Now we can do some questions based on this to bring about more clarity on this. So I have taken two questions here based on this. First question says that the products obtained in chlor-alkali process. Clearly we did this, that the products obtained is chlorine, hydrogen, and sodium hydroxide. So this one is correct. Now in the next one, that is the later part, as you can see this reaction, this is why is the electrolysis of concentrated solution of sodium chloride is called chlor-alkali process. Well, I told you chlor here, this word chlor has come from its product. The product is chlorine, right? Chloro what? Or chlor, sorry. And sodium hydroxide is an alkali, right? This alkali means the base which is soluble in water is called alkali, and therefore this name is called chlor-alkali process. Well, you should know what is electrolysis also. Electrolysis is what? Passing electricity through an electrolyte is called electrolysis. Can do more questions. Two more questions based on this. It says when a concentrated aqueous solution of a substance X, right, there is a substance X is electrolyzed, means electricity is passed, then sodium hydroxide, chlorine, and hydrogen gas are produced. We have to name the substance X and the process so involved. Just now did here that this is a reaction. I mean, when electrolysis of what is this as substance X must be brine, that is NaOH plus, NaCl, that's sodium chloride. This is sodium chloride, NaCl plus water. So this is brine, and that is the substance X. And the process here just discussed that this is chlor-alkali process, the process in which sodium hydroxide, chlorine gas, and hydrogen gas is released. Now the second question says that, the next one says that when chlorine and sodium hydroxide being produced during this electrolysis is allowed to mix, a new compound is formed, and we have to write down the name of the compound and its uses. This is another important. So the chlorine, this is chlorine in this case, right, the gas and the sodium hydroxide. This together are used in making bleaching powder, right? It is used in making bleaching powder. This should know, so you should know that it is used in making bleaching powder. And name this chemical, we named it, and its uses. Bleaching powder is used as a disinfectant. This disinfectant which is used can be in disinfecting water. Primarily, it is used in disinfecting water. As you know that the chlorine gas is used in manufacturing of bleaching powder. So when this bleaching powder is this bleaching powder, when it is dissolved into water, it also produces chlorine gas, and that is responsible in killing germs. Continuing with its uses, as we discussed, this hydrogen gas is used as a fuel, and it's also used in hydrogenation, conversion of unsaturated fat into saturated, that is making saturated fat. Now, chlorine, which is already used in PVC, polyvinyl chloride, water treatment, and also CFC. Now, from these two products, when hydrogen and chlorine combines, it gives hydrochloric hydrogen chloride gas, or can be hydrochloric acid, which is used in cleaning steels and in medicines. Now, further, this sodium hydroxide, we have already done that it is used in degreasing metals, soaps, and paper making industries. The chlorine, this chlorine so obtained during this reaction or the electrolysis, and the sodium hydroxide together is used to make bleach, and bleach is used as a household bleach bleaching fabrics. That means removing colors, right? Removing color from fabrics. Right? These are their uses. Now we are going to understand, we are going to do questions based on this. So it is used in hydrogenation. Which one is used in hydrogenation? That is hydrogen, right? So hydrogen is used in hydrogenation is a process in which the unsaturated fat is converted into saturated. The next one is, it is the next, that means I'm over here. It is used in the production of hydrochloric acid. Just now we did that hydrogen and chlorine produced during the reaction is used in the production of hydrochloric acid. So we'll say that the substances we use is number one is chlorine and the second is hydrogen. In the next part, what we have to do is involved in the production of detergent. So detergents, soaps or detergents, right, are the same here. So this is sodium hydroxide, which is used in the making of soaps and detergents. So we'll say sodium hydroxide in this case. The next one is one which is used in degreasing metal. Like as you can see here, that sodium hydroxide is used in degreasing metal. So we'll be writing this sodium hydroxide as used for degreasing metal. Next is the next one is, it is used in medicines and cosmetics. Like you can see, the one which is used in medicines, cosmetics is the HCl, and which is the option here is this hydrochloric acid. Next is, it is used in making used for production of bleaching powder. As I told you that sodium hydroxide and chlorine and sodium hydroxide together react to give bleach, and which is used. So what we'll say that the product obtained from sodium hydroxide and chlorine, to give bleach. Two last questions that we have taken on this chlor-alkali process. She says the electrolysis of an aqueous solution, that is aqueous solution of sodium chloride is brine here, right? Gives three products, name it. So clearly we know that three products are chlorine, hydrogen, and sodium hydroxide. Now, in the next part, they are asking during electrolysis of saturated solution. Saturated, you know that the solution in which no more solute can be added. So it's a, as I told you, brine is a highly concentrated solution of sodium chloride. So they're asking where is chlorine gas is formed. As you can see, chlorine is formed near anode, right? At anode, not near anode, sorry. It is, chlorine gas is released at anode, right? And then hydrogen gas, clearly you can see in the figure, is produced at cathode. And sodium hydroxide is produced near cathode, right? So we can see it's do the selection here, that chlorine is released at anode, hydrogen at cathode, and sodium hydroxide near cathode.